Hi friends. So this week we continue our discussion by Dr. Praful Dikshit. In this series, while trying to establish the importance of null hypothesis significance testing and also the debate surrounding its use, we are first trying to address the underlying concepts to gain a richer understanding of the topic. Now over to Dr. Praful Dikshit.
So, hi everybody, this is Dr. Praful Dikshit, and in the last video, we got to understand that significance is of two types in terms of its results. So, it's the substantive significance as measured by the variable attribute or the effect size, and the statistical significance, which is measured by the p-value. Also, you'll recall from the previous video that we discussed a Shotput example scenario to drive home the concept of p-value, and thereby we established the difference between substantive and statistical significance. So we also posed a question in the last video, and we asked you to come up with several examples of p-value. So let me come back to that in a bit, but before that, I want to emphasize and touch upon a very important point. The point is the importance of the level of significance or confidence of our results. Now, do you think that the level of significance we choose to test our results plays any role in the efficacy or the validity of our results? Now, for this, let's briefly go back to the summary of the results of the shot-put example scenario in the previous video. Now, as you can recall from that example scenario, the confidence level in that study was 80% and the significance was 20%. Now, while this may be good enough in this scenario for letting Mr. Blue compete in the state level competitions, but however, do you think that it is good enough for situations wherein there is a question of life and death? Maybe wherein we are conducting the trials of a life-saving drug. So basically, uh, do you think we should set up our p-value in that case, the stringency level to a higher value, a higher level? Let me just explain this with another creative example, which is a COVID-19 scenario. So the scenario here is that COVID-19 is spreading around the world, and here is this little village of 100 families, and they've been instructed by the local medical administration to maintain strict social distance. The administration has come up with a specific protocol and on social distancing, and the local medical team is trying to keep the village corona free. The research unit of the medical team also wants to measure the effect of their specific social distancing protocol on the COVID-19 prevention in this village. They're pretty confident that their social distancing protocol for COVID-19 can help keep the village corona free, and if successful, it can be emulated in other villages also. So they decide to train the villagers on the protocol, and they do it on what we call day zero, and they set up a field experiment for the next 10 days. Okay, they appoint a silent observer in the village who lives in the village for the next 10 days and sends a daily email report to the research team in the district. So the observer starts his observations, and according to his observations on day one, in the village, everybody is following the social distance protocol, and there is a village well from which one member from each family has to come to the well to fetch water, which is an essential commodity, and there's no other water source in the village. And every day, one person from another village also visits the village for disinfecting the well. Let's see this. Let's rewind a bit and see what is really happening here. So everybody is following social distancing. One person at a time from each family is approaching the well, and this lady, this disinfection worker, she's doing her job well, and she's coming and disinfecting the well, and everybody is following the protocol on day one. So on day two, everything goes well. People maintain social distance in the families as well as at the well, and it's business as usual for day two. Day 3 to 5 is the same business as usual, and everything goes well on day 3 to day 5 as well. Now, day 6, everything goes well except one of the members of a family fails to maintain social distance and with whom the well disinfection worker interacts a bit too closely, who also incidentally coughs at the same time. The villager accepts some food material sent through the latter by his relatives in the other village. And the other village, by the way, is highly disinfected, highly infected, and highly affected by the coronavirus. So let me just rewind it a bit to see what is exactly happening here. And as you can see, the disinfection worker, she's going and here, okay, this is the point where she's interacting with this person and they do it too closely and okay. And then she goes off. Now, she might be infected, she might not be infected because she comes from from a village which is highly infected, and usually it is assumed that since she is a health worker, she might not be infected. But let's find out. There are reportedly many positive cases in the other village, and normally everything goes well after the 6th day, and from the 6th day to the 10th day, uh, we don't know what exactly happens. But then let's find out on day 10. So as we see, this disinfection worker is apparently infected, which is apparent from this red color on her, and she's a bit uneasy. And as shown here, she does her job, and she's going back. And while going back, she faints and falls down, and all the people surrounded her. So next, what happens is the observer appears on the screen, is in green, and an ambulance comes and fetches the worker and also the observer who appears on the scene, and they help the worker to board the ambulance. The ambulance also has inside the medical team, and they're really surprised by the results since a few people in the village have now started reporting some COVID-19 symptoms. The medical team, which came in the ambulance, visits the households and they want to know the level of infection. So the team goes out in the village with the testing kits and they randomly test 100 families and they record the results. And the results show that out of the 100 families, 90 families are not infected. Okay, and there are 8 families with one infected member, and there are 2 families with all members infected. Now, the infected families are taken to the outside quarantine facilities, and the rest of the families are home quarantined with the government making sure a disinfected water supply source is provided to the village for the quarantine period. That's beside the point. So here's this little summary of the scenario. As per the scenario, the village V, which was so far free from corona, and there was a medical team which came up with a social distancing protocol, which we call SDP. The sample size was 100 families, and the assumption that we made here was that SDP keeps village corona free. Now, we made an opposite of this assumption, which we call our null hypothesis, which is opposite to the hypothesis that we assume, is that the SDP doesn't keep the village corona free. And we set up a test and experiment, and according to which the SDP field observation test was that the effect was being measured in terms of the effectiveness of SDP through the rate of infection or disinfection in the village. So the results showed that in terms of the number of families with infected members, there were 90 families with no infected member, and there were 8 families with at most one infected member, and there were 2 families with all infected members. So the overall mode effect was that there was no one infected. I mean, the overall result was this. Okay, now the confidence level in this case we can say was 90%, and the significance level, the p-value for us in this case was 10%. Now, let's imagine a scenario wherein we have a stringent measure, uh, say 95%. Are these results uh, good enough in terms of the confidence level of 95%? If we compare it with the previous example, as in the Shotput example, these results are good enough. In that case, it was 80% confidence, now it is 90% confidence, but it is still not good enough if we have to fall in line with the standards. And the standard across the board, the value that is arbitrarily set but is a norm, is 95% of confidence level, which means a significance level of 5%. Now this standard level of confidence, we call it beta, and the standard significance level we call alpha. So in this case, since the p-value of our results, which is 10%, is greater than alpha, which is 5%, the protocol is not effective in keeping village corona free, because we cannot reject the null hypothesis. And what was the null hypothesis? The null hypothesis was that the protocol cannot keep the village corona free. So basically we have introduced two new terms or concepts here. One is the null hypothesis, or the alternative hypothesis, which is nothing but the initial assumption. And second is the alpha level, which is the standard we set for testing the significance of the results. Now, in this case, the results are better than in the case of the Shotput scenario. However, they're still not up to the mark going by the usual standard or the alpha level for such studies. So as we've seen, null hypothesis is the opposite of whatever we are trying to prove based on the observed outcome. And alternative or alternate hypothesis is what is it that we are trying to prove based on expected outcome or the effect. Now let's see if how we can apply this information in terms of what we've learned so far about significance testing and p-value. Let's have a small review. So examples of p-value are, as we talked about in the question, 0.045, 0.0634, or 0.0015, etc., etc. And all the values, as you can see, are between 0 and 1. And this is so because these are all probabilities, and probabilities are measured in fractions, right? And these are probabilities of measuring the actual attributes and the effects of population from a sample which may be so by chance, so as to minimize this chance. Therefore, in terms of hypothesis testing, we are measuring the probability of accepting what we are trying to prove, the alternative hypothesis, or in other words, the probability of rejecting the opposite of the same, which is also called the null hypothesis, through p-value. So as usual, we have a question for the next session, and that is, can we go wrong in our effort to measure this probability? And also, what is the chance we can go wrong? So in the next video, we will discuss the answer to this and explain the very important concept of type 1 and type 2 errors in null hypothesis significance testing. So thanks for watching. Do like and share this video. Your comments and questions are welcome in the comment section at the bottom of the video. And also do subscribe to my channel Stratosphere Research at this link right beside the red arrow. See you in the next video. Till then, stay safe, goodbye, and have a good day.